Let's talk about types of acids. Acids can be distinguished by their strength or concentration, and we can differentiate the strength and the concentration as being weak or strong versus concentrated or dilute. So for now, I'm going to ask you to just take down the diagram into your notebook. I will go on to explain what is strength versus concentration. But just to note, if a solution is weak, it cannot be strong. If it is concentrated, it cannot be dilute. But a solution could be weak and concentrated. It can be weak and dilute, or it can be strong and concentrated, or strong and dilute. Let's talk about the strength of an acid. Based on the nature of the acid, this will determine its strength. So an acid, we say, forms a particle called a hydrogen ion, but we have not discussed how many hydrogen ions it would form. So the strength of an acid really refers to the extent to which an acid separates to form these hydrogen ions. That means we can have an acid which separates or dissociates to give many hydrogen ions, or we can have an acid which dissociates or separates to form a small amount of hydrogen ions. So let's look at what is a strong acid. Given what I have talked about, this would mean a strong acid is one which dissociates or breaks down to give many hydrogen ions. Right, so it breaks down, or even if you want to use the word dissociate. And these strong acids will form many hydrogen ions. Some examples of strong acids include hydrochloric, sulfuric, and nitric acid. What does this mean for weak acids? This should mean that a weak acid, when in solution, would break down to form fewer hydrogen ions. Can you think of any weak acids you might know of from everyday life? Some examples include citric acid found in lemons, carbonic acid in fizzy drinks, and ethanoic acid in vinegar. So all of these uh, substances we can ingest, and therefore it would make sense that they are weak acids, as strong acids would corrode the lining of the stomach. Just to summarize between strong acids and weak acids, they are determined by their nature, meaning that an acid can be known as being strong or weak. So you would have to learn off your list of acids which are strong or weak and remember them. And if you see any examples on this slide that I have not called out, please take it down into your note. Let's talk about the concentration of acids. In the previous chapter, we looked at solutions where a solution can be described as dilute, concentrated, saturated, or supersaturated. I am going to build on what we have discussed, where it was said a dilute solution contains a small amount of solute in a given amount of solvent, and a concentrated solution has a large amount of solute in a given amount of solvent. So instead of using the words amount of solute, I'm going to change that to talk about the quantity of a solute or the quantity of a chemical. And in chemistry, we use the term mole, that's M-O-L-E, in terms of how we describe the quantity of a chemical in a substance. For example, in a dilute solution, we would say there is a small number of moles of solute, and in a concentrated solution, we would say there's a large number of moles of solute. So let's take down our definition of what is the concentration of an acid, and the concentration looks at the number of moles of the acid in the solution, keeping in mind the solution also contains the solvent water. So our solute, which is the acid, is being compared to the volume of water. And this diagram here shows the difference between dilute to concentrated, where dilute would have a low number of moles of our solute and concentrated a large number of moles of solute.